In this question, we're asked to find 10% of £320. And now to find 10%, we need to divide 320 by 10. But it's important to realise that this trick only works for 10%. To find 10% of a value, we always divide by 10. But that doesn't mean that if you find 20%, for example, you would divide by 20. And so going back to our question, to find 10% of £320, well, 320 divided by 10 is equal to 32. And so 10% of £320 is equal to £32. And we get the 1 mark in this question for getting the correct answer of £32. Now in this question, we're asked to write 0.8 as a percentage. So let's first define what we mean by percentage. A percentage is referring to a fraction out of 100. We know that 0.8 is equal to 8 out of 10. Now as a percentage, we want this value to be out of 100, and so we can multiply the numerator and the denominator by 10. And so we end up with 80 out of 100. Now we said a percentage was defined as the number over 100. Now because 0.8 is equal to 80 over 100, we've found that 0.8 is equal to 80%. Which allows us to get the 1 mark needed in this question. In part A, we need to work out the value of 84 divided by 3, which we can do so using the bus stop method. Well, how many 3's go into 8? We have 3, and we have 6, but we don't have 9 because 9 is bigger than 8. So 3 goes into 8 2 times, with a remainder of 2. And now you need to see how many 3's go into 24, and that's equal to 8. And so we found that 84 divided by 3 is equal to 28. Next we need to do 0.17 multiplied by 6,000. And we can use grid method to help us with this. But before we do that, we can see that 0.17 splits into 0.1 plus 0.07, which will help us when we do grid method. So now we'll do 6,000 multiplied by 0.1 plus 6,000 multiplied by 0.07. 6,000 multiplied by 0.1 is equal to 600. And 6,000 multiplied by 0.07 is equal to 420. And so adding 600 and 420 together, using column addition, well 0 plus 0 is equal to 0, 0 plus 2 is equal to 2, and 4 plus 6 is equal to 10. And so we found that 0.17 multiplied by 6,000 is equal to 1,020. And finally, we have minus 2 all to the power of 3, which is equal to minus 2 multiplied by minus 2 multiplied by minus 2. But we'll start by minus 2 multiplied by minus 2. So a negative number multiplied by a negative number is equal to a positive number. And so minus 2 multiplied by minus 2 is equal to 4. And now we're left with 4 multiplied by minus 2. Now we also know that a negative number multiplied by a positive number will result in a negative number. And so 4 multiplied by minus 2 is equal to minus 8. And so we've found that minus 2 all to the power of 3 is equal to minus 8. We get the 3 marks in this question for getting each part correct. And so we get 1 mark for part A, 1 mark for part B, and finally 1 mark for part C, allowing us to get the full 3 marks needed in this question. In this question, we're given a diagram which shows a square-based pyramid. And in the first part of this question, we need to identify how many faces this pyramid has. And so we can use a diagram to help us. We can use different colours for each face. And so we have the face at the very bottom, which is the base of the pyramid. Then we have this face on the side, another face at the back, this face on the other side, and finally this face at the front. And so using our very messy diagram, we can see that this square-based pyramid has 5 faces. We need to find out how many edges that this pyramid has, and so we can annotate our diagram in order to do this. So we can already see 4 edges at the very bottom. And to hold the side faces together, we can see that we have this edge and another edge over here, and another edge here, and finally another edge here. And so counting the lines that we've drawn, we can see that there are 8 edges in total. So we can say that this pyramid has 8 edges. And the 2 marks in this question come from each of the 2 parts. We get 1 mark for identifying how many faces that this pyramid has, and the second mark for identifying how many edges that the pyramid has, allowing us to get the full 2 marks needed in this question. In part A, we're asked to write down the coordinates of point B. Now coordinates are always in the form x, y, with the x coordinate coming first and the y coordinates coming second. So let's start by finding the x coordinate of point B. Now looking at the x-axis, we can see that the x coordinate of point B is 4. And looking at the y-axis, we can see that the y coordinate of B is equal to 5. And so we can say that the coordinates of point B are 4, 5. Now we need to find the coordinates of the midpoint of AB. Let's draw a line AB by joining points A and B together. Now to find the midpoint of AB, we need to know the coordinates of A and the coordinates of B. We can see that the coordinates of A, looking at the x-axis first, is -2, and then the y-axis, 3. And we know that the coordinates of B are 4, 5. So to find the midpoint, well, the x-coordinate of the midpoint will be the number in between -2 and 4, and the y-coordinate of the midpoint will be the number in between 3 and 5. The number in between -2 and 4 is equal to 1, and the number in between 3 and 5 is equal to 4. And so the midpoint of line AB is equal to 1, 4. And now in part C, we need to draw on the grid the line with equation y is equal to -3. So we can see that the point at which y is equal to -3 is over here. And so the line with equation y equals -3 will mean that no matter what the x-coordinate is, y would always be equal to -3. So we can see that drawing a horizontal line which goes through the point y is equal to -3 will always have a y-coordinate of -3, regardless of what the x-coordinate actually is. And so we've now correctly drawn the line with equation y is equal to -3 on the grid above. And so we get the 3 marks in this question. We're getting part A correct and saying that the coordinates of point B are 4, 5. For part B, and we're saying that the coordinates of the midpoint is 1, 4. And finally, for part C, we're correctly drawing the line with equation y is equal to -3, allowing us to get the full 3 marks needed in this question. In this question, we're given the instructions for making a drink. We're told to add 100 milliliters of juice to 2 liters of water. Dev uses 5 liters of water to make the drink. And we need to find out how much drink he has made. Based on the instructions that we've been given, let's find out how much drink that this makes. Now here's where we need to be careful of units. The quantity for the juice is given in milliliters, whereas the quantity for the water is given in liters. So let's convert from liters into milliliters. And 2 liters is equal to 2000 milliliters. So we can see that the amount of drink that these instructions make is equal to 100 plus 2000, which is equal to 1200 milliliters. We're told that Dev uses 5 liters of water to make the drink. We need to figure out what Dev has multiplied by to get from 2 liters to 5 liters. So to get from 2 to 5, we have to multiply by 2.5. Which means that the total amount of drink will also be multiplied by 2.5. The original recipe will make 1200 milliliters of drink. We need to multiply by 2.5 to find out how much drink he has made by using 5 liters of water. And so 1200 multiplied by 2.5 is equal to 5250 milliliters of water, and be careful not to mix up the units. And so we can see that Dev has made 5250 milliliters of drink. Now this question is worth 3 marks, so let's take a look at where these marks are allocated. We get the first mark for finding the correct multiplier of 2.5. We get the second mark we're using this multiplier in order to find how much drink he has made using 5 litres of water. And to do this, we did 1200 multiplied by 2.5. And finally, we get the third mark for getting the correct final answer of 5,250 millilitres, which could also be written as 5.25 litres, allowing us to get the full 3 marks needed in this question. In this question, we're told that there are 3 types of chocolates in a box. There are 6 plain chocolates, 8 milk chocolates, and 10 white chocolates. Ben takes at random a chocolate from the box, and in part A, we're asked to write down the probability that Ben takes a plain chocolate. Let's start by finding out how many chocolates there are in the box in total. And so 6 plus 8 plus 10 is equal to 24 chocolates in total. Since there are 6 plain chocolates in the box, the probability that Ben takes a plain chocolate would be 6 out of the total of 24. Now we can simplify this fraction even further by dividing both the numerator and the denominator by 6, leaving us with an answer of 1 out of 4. And so we can see that the probability that Ben takes a plain chocolate from the box is equal to 1 over 4. Now in part B, we're told that Dion takes 2 chocolates from the box, and we need to write down all of the possible combinations of types of chocolates that Dion can take. We can see that he can take a plain chocolate, and then a plain chocolate again, or he could start by taking a plain chocolate and then a milk chocolate, or a plain chocolate and then a white chocolate. But he could also take a milk chocolate first, and then a white chocolate, or a milk chocolate, and then a milk chocolate again. And we're not going to do a milk chocolate and a plain chocolate, because we've already looked at plain and milk, which is the same thing in a different order. And finally, looking at the white chocolate, well, we're not going to write down white chocolate and then plain chocolate, because we've already written plain and white. And we're not going to write down white chocolate and then milk chocolate, because we've already written down milk and white. And so the last combination of the types of chocolates that Dion can take is white chocolate and then a white chocolate again. Which means that we've now written down all of the possible combinations of types of chocolates that Dion can take. Now this question is worth 4 marks. In part A, we get the first mark for a correct numerator, and the second mark for a correct denominator. And in part B, we get the full 2 marks for the complete and correct list of all of the possible combinations. And so we've now achieved the full 4 marks needed in this question. In this question, we're told that 8 identical pens cost £12, and we need to work out the cost of 10 of these pens. And so to do this, we need to first find the price of 1 pen. So to get from 8 pence to 1 pen, we need to divide both sides by 8. £12 divided by 8 is equal to £1.50. And so we found that the cost of 1 pen is equal to £1.50. Now that we've found the cost of 1 pen, we can use this value in order to find out the cost of 10 of these pens. To get from 1 pen to 10 pens, we want to multiply both sides by 10. And so £1.50 multiplied by 10 is equal to £15. And so we've now found that the cost of 10 of these pens is equal to £15, which we can write down in the space provided. Now this question is worth 2 marks. We get the first mark for finding the cost of 1 pen, and we're saying that the cost of 1 pen is equal to £1.50. And the second mark is for multiplying this value by 10 in order to find out that the cost of 10 pence is equal to £15, allowing us to get the full 2 marks needed in this question. In this question, we're given 5 fractions, and we're told that one of these fractions is not equivalent to 1 out of 4. And in part A, we need to identify this fraction and write it down. So let's work through these fractions in order. We first have 2 out of 8, and now to see if 2 out of 8 is equivalent to 1 out of 4, let's divide the numerator and the denominator to see if we get an answer equal to 1 over 4. Now when we divide the numerator by 2, we get 1, and dividing the denominator by 2, we get 4. And so 2 out of 8 is equivalent to 1 out of 4. Now let's move on to 10 out of 40. When we divide the numerator by 10, we get 1, and when we divide the denominator by 10, we get 4. And so 10 out of 40 is equivalent to 1 out of 4. Then we have 12 out of 48. Now when we divide the numerator by 12, we get 1, and when we divide the denominator by 12, we get 4. And so 12 out of 48 is equivalent to 1 out of 4. Next we have 5 out of 24. When we divide the numerator by 5, we get 1, but when we divide the denominator by 5, well, 24 divided by 5 is not equal to 4, and so 5 out of 24 is not equivalent to 1 out of 4. But before we write this down, let's take a look at 20 out of 80, just to make sure that we've got the right answer. Well, 20 out of 80, when we divide the numerator by 20, we get 1, and when we divide the denominator by 20, we get 4. And so 20 out of 80 is equivalent to 1 out of 4. And so the fraction that is not equivalent to 1 out of 4 is 5 over 24, which we can write down below. Now in part B, we need to work out 2 out of 7 plus 1 over 14. Now when we add or subtract fractions, we need to make sure that we have a common denominator. Well, we can make a common denominator of 14 by changing the first fraction to have a denominator of 14. Now 2 over 7. To get a denominator of 14, we want to multiply both the numerator and the denominator by 2. And so 2 out of 7 is equivalent to 4 out of 14. So now we can say that 2 over 7 plus 1 over 14 is the same as saying 4 over 14 plus 1 over 14. And now that we have the same denominator, we can go ahead and add the numerators together and leave the denominators the way they are. And so 4 over 14 plus 1 over 14 would be equal to 5 over 14. And so we've found that 2 over 7 plus 1 over 14 is equal to 5 over 14. And finally, in part C, we need to work out 4 over 5 divided by 3 over 10, giving our answer in its simplest form. Now when we divide by fractions, there's a trick that we can use, where we flip the second fraction and change the division sign into a multiplication sign, which we'll demonstrate below. 4 out of 5 divided by 3 over 10 is equal to 4 out of 5 multiplied by 10 over 3. And so like we mentioned earlier, we changed the division sign into a multiplication sign and flipped the second fraction. And so 3 out of 10 became 10 out of 3. Now that we have 4 over 5 multiplied by 10 over 3, we can multiply fractions as normal. And to do this, we multiply the numerators together and we multiply the denominators together. And so 4 over 5 multiplied by 10 over 3, well, 4 times 10 is equal to 40, and 5 times 3 is equal to 15. But we need to leave our answer in its simplest form. And so we can divide both the numerator and the denominator by 5. 40 divided by 5 is equal to 8, and 15 divided by 5 is equal to 3. And so in its simplest form, 4 over 5 divided by 3 over 10 is equal to 8 over 3. This value of 8 over 3 could also be written mixed number 2 and 2/3. Since both answers are equivalent, either one would still be correct. Now this question is worth 5 marks, so let's take a look at where each mark is allocated. In part A, we get the 1 mark for correctly identifying that 5 over 24 is not equivalent to 1 over 4. In part B, we get the first mark for finding the common denominator of 14 and making 2 over 7 equivalent to 4 over 14. And we get the second mark in part B for adding the two fractions together and showing that 4 over 14 plus 1 over 14 is equal to 5 over 14. Now in part C, we get the 1 mark for flipping the fraction and changing the sign, and for saying that 4 over 5 divided by 3 over 10 is equal to 4 over 5 multiplied by 10 over 3. And we get the second mark in part C for completing the calculation and for getting an answer in its simplest form of 8 over 3. which could also be written as 2 2/3. Whether you write down the answer as 8/3 or 2 2/3, you'll still get the correct answer and will gain the mark. And so we've now achieved the full 5 marks needed in this question. In part A, we need to solve 3x plus 7 is equal to 1. We can start by moving the 7 over to the other side, by subtracting 7 from each side, and so we're left with 3x is equal to minus 6. Now to solve for x, we want to divide both sides by 3, and so we're left with x is equal to minus 6 divided by 3, which is equal to minus 2. And so we can write down our answer in the space provided. Now in part B, we're told that f is equal to 6 and g is equal to 5. We need to work out the value of 3f minus 2g. So let's substitute these values in. 3f is equal to 3 multiplied by f. F is equal to 6, and so 3f is equal to 3 multiplied by 6. Then we have 2g, which is the same as 2 multiplied by g. G is equal to 5, and so 2g is equal to 2 multiplied by 5. Now we can simplify this. 3 times 6 is equal to 18. And 2 times 5 is equal to 10. And so we're left with 18 take away 10, which will give us an answer of 8. And so we found that 3f minus 2g is equal to 8. Now this question is worth 4 marks. We get the first mark in part A for moving the 7 to the other side and dividing both sides by 3. And we get the second mark in part A for getting the correct final answer that x is equal to minus 2. Now in part B, we get the first mark for substituting in the values of f and g, and for saying that 3f is equal to 3 multiplied by 6, and 2g is equal to 2 multiplied by 5. And the second mark in part B is for simplifying and for getting a correct final answer of 8. Allowing us to achieve the full 4 marks needed in this question. In this question, we're told to write down 3 different multiples of 4 that add up to 40. So let's start by listing a few multiples of 4. Now that we've written down some multiples of 4, we need to find a combination of 3 of these numbers which add up to 40. And you can see that there are quite a few possibilities that you might have. And so as long as your final answer are 3 different multiples of 4 that add up to 40, you'll be able to get the full 2 marks. So let's take a look at some of the different possibilities that we might have. We could have 8 plus 12 plus 20, which add up to 40. Or we could have 4 plus 8 plus 28, which add up to 40. We could have 4 plus 12 plus 24, which add up to 40. Or we could have 4 plus 16 plus 20, which add up to 40. And so we can see that we have 4 different combinations of different multiples of 4 that add up to 40. And so it doesn't matter which of these combinations that we write down as our final answer, because all of these are correct. But we do need to write down one of them. So in this example, we're going to use the numbers 8, 12, and 20. But any of the combinations in purple will still be correct. Now this question is worth 2 marks, and we automatically get the full 2 marks for writing down 3 different multiples of 4 which add up to 40. Allowing us to achieve the full 2 marks needed in this question. In this question, we're told that Helen has 80 books to sell. Each book is either fiction or non-fiction, and the ratio of the number of fiction books to the number of non-fiction books is 3 to 1. We're told that each book has a normal price of £10. Helen then reduces the price of all of the non-fiction books, and now all of the non-fiction books are half price. We're told that Helen sells all 80 books, and we need to work out the total amount of money that Helen will receive. Well, let's start by finding out the number of fiction books and the number of non-fiction books that Helen has. Now we're told that the ratio of the number of fiction books to the number of non-fiction books is 3 to 1. This means that we have 3 plus 1 equals 4 parts in total. Now this ratio means that 3 out of these 4 parts are fiction, and 1 out of the 4 parts is non-fiction. And so we can write this as a fraction. We can say that 3 over 4, so 3/4 of the total amount of books are fiction, and 1 over 4, so 1/4 of the total amount of books are non-fiction. Now we can use these fractions to find the number of fiction books and the number of non-fiction books. Now we know that there are 80 books in total. 3/4 of 80 is equal to 60. And since 3/4 of the books are fiction, we can say that there are 60 fiction books. And now 1/4 of 80 is equal to 20. 1/4 of the books are non-fiction, and so we can say that there are 20 non-fiction books. Now that we've found out the number of fiction books and non-fiction books, we need to work out the amount of money that Helen makes. We're told that each book has a normal price of £10, but the price of the non-fiction books are now half price, which means that the non-fiction books now cost half of £10, which is equal to £5. We have 60 fiction books, which are each sold for £10, and so the amount of money that Helen makes from the fiction books is equal to 60 multiplied by £10 each, which is equal to £600. Now we know that the non-fiction books now cost £5, and so the amount of money that Helen makes from the non-fiction books would be 20 multiplied by £5 each, which is equal to £100. And so we can say that the total amount of money that Helen will receive is equal to £600 plus £100, which gives us a total amount of £700. Now this question is worth 4 marks. We get the first mark for finding the number of fiction books. We get the second mark for finding the number of non-fiction books. We get the third mark for finding the amount of money that Helen makes from the fiction books and the amount of money that Helen makes from the non-fiction books. And we get the fourth and final mark for adding these values together and for getting a final correct answer that the total amount of money that Helen receives is equal to £700, allowing us to achieve the full 4 marks needed in this question. In this question, we're told that Ryan and Carl each get paid a basic pay of £60 per day. One day, Ryan also gets a bonus of 25% of his basic pay. And on that same day, Carl gets £20 in tips from customers. We need to work out the difference between the total amounts of money that Ryan and Carl each get. We'll start by finding the amount of money that Ryan makes on this day. We're told that Ryan gets a bonus of 25%, which means that we have a 25% increase of his normal pay. Now to find a 25% increase, we multiply the original amount by 1.25. And so on that day, Ryan was paid 60 multiplied by 1.25, which is equal to £75. Now we can work out how much Carl was paid. We're told that Carl receives £20 in tips from customers, which means that his total pay was £60 plus an additional £20, which will give us an answer of £80. Now that we've worked out how much they were each paid, we need to work out the difference between the total amounts of money that Ryan and Carl each get. And now to find the difference, we'll do £80 take away £75, which will leave us with an answer of £5. And so we've now found that the difference between the total amounts of money that Ryan and Carl each get is equal to £5. Now this question is worth 3 marks. We get the first mark for finding the total amount of money that Ryan makes. We get the second mark for finding the total amount of money that Carl makes. And we get the third mark for finding the difference between these values and for getting a final correct answer of £5. In this question, we're told that some people were asked if they like swimming, or cycling, or running. The table below shows the results for the males and the results for the females. And in part A, we need to draw a bar chart on the grid below to show this information. So we'll start by drawing our 2 axes. The vertical axis will represent our frequency, and so we can fill in the scale. We can see that the maximum frequency in our table is 8, and so our vertical axis needs to go up to a minimum of 8. Now given the size of our grid, we can go up in intervals of 1, and so we can have 0 all the way through to 8 on our vertical axis. Now on our horizontal axis, we'll split it into 3 parts, one for swimming, one for cycling, and one for running. Now that we have our 3 different sections, we can begin to draw our bars, and we can have separate bars for male and female. Now looking at our table, let's start with the swimming section. There are 2 males who like swimming, so we can draw a bar on our bar chart to represent this. We can also see from our table that there are 8 females who like swimming. Now let's move on to cycling. We know that there are 6 males who like cycling, and there are 5 females who like cycling. Now finally, let's move on to running. There are 4 males who like running, and 5 females who like running. But our bar chart isn't quite finished, because we need clear labels to represent male and female. Now we can do this using colours, or we can do this using labels. In this example, let's use colours. We'll fill in all of the male boxes in blue, and all of the female boxes in orange, and we'll draw a key at the top so that we know which is which. So now we've filled in each of the bars, and we have a suitable key to represent male and female. So we can see that all of the bars in blue represent the male results, and all of the bars in orange represent the female results. And so we've now drawn a complete bar chart, which represents the information in our table. Now in part B, we need to work out the percentage of the 30 people that are female. And we've included a screenshot of the table above for reference. Now to find the percentage of the total 30 people who are female, we need to find out the number of females. And so we have a total of 8 plus 5 plus 5, which is equal to 18 females. So we know that 18 out of 30 are female, and we need to write this as a percentage. Now percentage means out of 100, so let's see if we can manipulate this fraction to have a denominator of 100. Well, let's start by making it have a denominator of 10. To get from 30 to 10, we divide by 3. And so we can do the same to the numerator and the denominator. And so 18 divided by 3 is equal to 6. And 30 divided by 3 is equal to 10. Now to make the fraction out of 100, we can multiply both the numerator and the denominator by 10. And so when we multiply both the numerator and the denominator by 10, we'll get a fraction of 60 out of 100. And so 60 out of 100 is equivalent to 60%. And so we've found out that the percentage of the 30 people that are female is equal to 60%. Now this question is worth 6 marks, so let's take a look at where these marks are allocated. In part A, we get 1 mark for a correct scale on our vertical axis, which goes up in regular intervals. In our case, we have a vertical axis which goes up in intervals of 1. We get the 2nd mark in part A for having a correct horizontal axis with correct labels for swimming, cycling, and running. We get the 3rd mark for drawing in the bars which correctly represent the data given to us in the table. And the 4th mark in part A is for a key which allows us to identify the data for male and female. Now in part B, we get 1 mark for identifying that 18 out of the 30 people are female. And we get the 2nd mark for correctly converting this fraction into a percentage, and for showing that 18 out of 30 is equivalent to 60%. And so we've now achieved the full 6 marks needed in this question. In this question, we're given a table which shows information about the ages of all of the people at a party. And in part A, we need to work out the total number of people who are aged 40 or less. Now looking at our table, we can see that the people who are aged 40 or less will all fall in these first 3 groups. And so we can add these frequencies together. So the number of people who are aged 40 or less would be 6 plus 16 plus 10, which is equal to 32. Now Andy says that the range of ages is 39, because 50 take away 11 is equal to 39. And in part B, we need to explain why the range might not be 39 years. First, let's identify what the word range means. In this context, the range of ages would be the oldest age take away the youngest age. And so what Andy does is he looks at the oldest possible age, which is 50, and the youngest possible age, which is 11, and says that the range of ages is 39. But this might not always be the case, because we don't actually know what the oldest age is, and we don't know what the youngest age is. For example, looking at the last group, which is 41 to 50, someone might not be 50 years old, and the oldest age in that group might be 45, for example. And looking at this top group, the range is 11 to 20, but that doesn't mean that the youngest person is 11 years old. The youngest person could be 18. And so our answer to part B is that the range might not be 39 years, because we do not know the exact age of the oldest or the youngest, because we have grouped data. And so we've now correctly answered part B and said that the range might not be 39 years, because we don't know the exact age of the oldest person or the youngest person. Now this question is worth 2 marks in total. We get the first mark for correctly answering part A, and for finding that the total number of these people aged 40 or less is equal to 32. And we get the second mark in part B for explaining why the range might not be equal to 39 years. In this question, we're given a diagram which shows a quadrilateral ABCD. We need to find out whether AB is parallel to DC, giving a reason for our answer. Now in parallel lines, co-interior angles add up to 180 degrees, so let's draw a diagram below so that we can understand what we mean. So when two lines are parallel and they're intersected by another line, we have two co-interior angles, and these co-interior angles are x and y. So for these two lines to be parallel, x plus y will always be equal to 180 degrees. So looking at our quadrilateral above, if AB is parallel to DC, angle ABC plus angle BCD would add up to 180 degrees. So let's find out if that's true. Angle ABC plus angle BCD is equal to 120 degrees plus 57 degrees, which is equal to 177 degrees. But like we said, if AB and DC are parallel, angle ABC plus angle BCD would be equal to 180 degrees. 177 degrees is not equal to 180 degrees, and so we can say that line AB is not parallel to line DC, and we need to write down a sentence or two to explain why this is. And so we've now proven that AB is not parallel to DC because 177 degrees is not equal to 180 degrees, and co-interior angles in parallel lines should add up to 180 degrees. Now this question is worth 3 marks. We get the first mark for adding together angle ABC and angle BCD, and for getting a total of 177 degrees. We get the second mark for comparing this value with 180 degrees, and for noting down that 177 degrees is not equal to 180 degrees. And we get the third mark for a correct explanation that because 177 degrees is not equal to 180 degrees, AB and DC are not parallel, because in parallel lines, co-interior angles should add up to 180 degrees, and in this case they don't. And so we've now achieved the full 3 marks needed in this question. In this question, we're told that Irina sells ice creams. One day, she sells 80 ice creams, and the next day, she sells 108 ice creams. We need to work out the percentage increase in the number of ice creams she sells. Let's start by writing down how we find a percentage increase. And so to find a percentage increase between two quantities, we'll do the difference divided by the original, all multiplied by 100. The original number of ice creams is equal to 80. If she sells 108, the difference would be 108 take away 80. And so we can write down that 108 take away 80 is equal to 28. Now that we've found the difference, we can find the percentage increase. We said that the percentage increase is the difference divided by the original, all multiplied by 100. And so we would do 28 divided by 80, all multiplied by 100, which is equal to 35. And so we can say that the percentage increase in the number of ice creams that she sells is equal to 35%. Now this question is worth 3 marks. We get the first mark for finding that the difference is equal to 108 take away 80, which is equal to 28. We get the second mark for a process to find the percentage increase by doing 28 divided by 80, all multiplied by 100. And finally, we get the third mark for the correct answer, that the percentage increase in the number of ice creams that she sells is equal to 35%. And so we've now achieved the full 3 marks needed in this question. In this question, we're told that Dimitar has 20 sweets, and we're told that Pip also has 20 sweets. We're told that Dimitar gives Pip X sweets, and then Dimitar eats 5 of his sweets. We're then told that Pip eats half of her sweets. We need to write expressions for the number of sweets that Dimitar and Pip now have. We're told that they both originally start with 20 sweets. Well, now we're told that Dimitar gives Pip X sweets. If he gives Pip X sweets, that means he loses X sweets. And so we can represent this as a subtraction. And so the number of sweets that Dimitar now has is 20 take away X. Well, now let's think about the expression for Pip. If Dimitar gives Pip X sweets, that means she has X more sweets than she had before. And so we can represent this as an addition. And so Pip now has 20 plus X sweets in total. We're then told that Dimitar eats 5 of his sweets, which again we can represent as subtraction. And so the new expression for the number of sweets that Dimitar has is 20 take away X, like we had before, and then take away 5, because he eats 5, which we can simplify into 15 take away X. We're then told that Pip eats half of her sweets, which means the number of sweets that she has divides by 2. And so we can say that her new expression is equal to 20 plus X, all divided by 2. So we can write these final expressions in our answer box below. We said that the expression for the number of sweets that Dimitar has is equal to 15 take away X. And we said that the expression for the number of sweets that Pip has is equal to 20 plus X divided by 2. This question is worth 3 marks. We get the first mark for the first stage of working out, and for realising that after Dimitar gives Pip X sweets, the expression for Dimitar is 20 take away X, and the expression for Pip becomes 20 plus X. We get the second mark for a correct final expression for Dimitar, and for finding that the number of sweets that he now has is 15 take away X. And we get the third mark for the correct final expression for the number of sweets that Pip has, and for finding that she has 20 plus X, all divided by 2, sweets in total. And so we've now achieved the full 3 marks needed in this question. In this question, we're asked to factorise y squared plus 27y. And so to factorise this, we need to find the highest common factor of both terms. And so the highest common factor of both y squared and 27y is equal to y. And so now we can place y outside of the brackets. We need to find which values are multiplied by y to give both y squared and 27y. And so we'll start with y squared. To get from y to y squared, we multiply by y. And to get from y to 27y, we multiply by 27. And so we can say that y squared plus 27y, fully factorised, is equal to y brackets y plus 27. Now in part B, we're asked to simplify t cubed all to the power of 2. And so there's a very specific index law that will need to help us answer this question. And the law is that a to the power of x all to the power of y is equal to a to the power of xy. And so in this situation, t to the power of 3 all to the power of 2 is equal to t to the power of 3 times 2. And so we can say that t to the power of 3 all to the power of 2 is equal to t to the power of 6. Finally, in part C, we're asked to simplify w to the power of 9 divided by w to the power of 4. And there's another index law that we can use to help us. A to the power of x divided by a to the power of y is equal to a to the power of x minus y. And so we can therefore say that w to the power of 9 divided by w to the power of 4 is equal to w to the power of 9 minus 4. And so we can simplify this and say that w to the power of 9 over w to the power of 4 is equal to w to the power of 5. Now this question is worth 3 marks, and Part A, Part B and Part C are all worth 1 mark each. And to get the full 3 marks for this question, we'll need to get each part, A, B and C, fully correct. Now we've gotten all parts correct, and so we can say that we've achieved the full 3 marks needed for this question. In this question, we're given a diagram which shows a square with perimeter 16 centimeters. And now we need to work out the proportion of the area inside the square that is shaded. So we can start using the properties of a square in order to find out the missing length. If a square has perimeter 16 centimeters, we know that each side in a square is equal, which means that the length of each side is equal to 4 centimeters. Now this means that we can now find out the missing length. If we know that the part above this is 2 centimeters, the total length of this line is 4 centimeters, and so this new purple line is 4 take away 2, which is equal to 2 centimeters. Now we can apply the same logic over here. We have a 3 centimeter line, and we're missing a certain amount in order to get to 4 centimeters. And so the small purple line over here is 4 take away 3, which is equal to 1 centimeter. Well, now we can go ahead and find out the proportion of the area inside the square that is shaded. Now the shaded area is a funny sort of shape, and it's not something that we can easily work out the area of. But what we can do is work out the area of the unshaded regions. We've now outlined these unshaded regions in order to see which ones we're talking about. And we can see that we're left with 2 right-angled triangles. Now we can work out the area of a right-angled triangle by doing area is equal to base times height divided by 2. So let's call this triangle 1 and this triangle 2. Looking at triangle 1, we can say that the base is equal to 4 centimeters and the height is equal to 2 centimeters. So the area is 4 multiplied by 2, or divided by 2, which is equal to 4 centimeters squared. Now let's look at triangle 2. We have a base of 1 centimeter and a height of 4 centimeters, and so A is equal to 1 times 4 divided by 2, which is equal to 2 centimeters squared. Now let's find out the area of the total shape. Now to find the area of the square, we do base multiplied by height. And so for our square, we have an area of 4 multiplied by 4, which is equal to 16 centimeters squared. Now we can see that the total unshaded area is equal to 4 plus 2, which is equal to 6 centimeters squared. And so we can now work out the area of the shaded region. So the area of the shaded region is the area of the entire square, take away the areas of the unshaded regions. And so we can say that the area of the shaded region is equal to 16 take away 6, which is equal to 10 centimeters squared. But in our question, we were asked to work out the proportion of the area inside the square that is shaded. And so we can turn this into a fraction. The proportion of shaded area. Now the proportion of the shaded area is the area of the shaded region divided by the total area, which is 10 over 16. Now we can simplify this and get an answer of 5 over 8. So we can now say that the proportion of the area inside the square that is shaded is equal to 5 over 8. Now this question is worth 5 marks, so let's take a look at where these marks are allocated. The first mark is for using the side length of 4 centimeters, which we've shown clearly in our diagram. Now the second mark is for a method to find the area of one unshaded triangle. Now we've found the area of both unshaded triangles. We said the area of triangle 1 is equal to 4 centimeters squared, and the area of triangle 2 is equal to 2 centimeters squared, allowing us to get that second mark. Now the third mark is a method to complete the area for the total unshaded region, which we did when we did 4 plus 2 is 6 centimeters squared. Now the fourth mark is to find the total area of the shaded region by doing the area of the entire square, take away the areas of the unshaded regions, and so we found that the area of the shaded region is equal to 10 centimeters squared. And finally, the fifth mark is for writing this as a proportion at the end, and so we said that the proportion of shaded area is equal to 10 over 16, which in simplest form is equal to 5 over 8, allowing us to get that fifth and final mark needed to get full marks in this question. In this question, we're told that David has designed a game. He uses a fair 6-sided dice and a fair 5-sided spinner. The dice are numbered from 1 to 6, and the spinner is numbered from 1 to 5. Each player rolls the dice once and spins the spinner once. A player can win £5 or win £2. Now for a player to win £5, the player must roll a 5 and spin a 5. For a player to win £2, the player must roll a 1 or spin a 1, or both. Now David expects 30 people will play his game, and each person will pay David £1 to play. Now in part A, we're asked to work out how much profit David can expect to make. Now as a general rule during probability, we can say that when we have or, it means we have to add, and when we have and, it means we have to multiply. The first thing that we can do is to start by thinking how much money David will make from the number of people who play. If David expects 30 people to play his game, and each person will pay David £1, he'll get a total amount of money, which is 30 multiplied by £1, which is £30. Now we need to consider how much money he will lose from the prize money of £5 or £2. So now let's look at the £5 situation. Now to win £5, the player must roll a 5 and spin a 5. If we had a fair 6-sided dice numbered between 1 and 6, just like we do in this question, the probability of rolling a 5 is 1 over 6. Now we're looking at the probability that the player rolls a 5 and spins a 5. So we can say we multiply now, and to spin a 5, we have a fair 5-sided spinner numbered between 1 and 5. And so the probability of spinning a 5 is equal to 1 over 5. And so the probability of winning £5 is 1 over 6 multiplied by 1 over 5, which will give us an answer of 1 over 30. Now a 30th of the total number of players, 1 over 30 multiplied by 30, which is equal to 1. And so now we've found that the probability of a player winning £5 is 1 over 30, which is only one player. Which means we can say that he's expected to lose £5 only one time. And so the loss of money for the win £5 one is 1 multiplied by £5, which is equal to £5. Now let's look at the win £2 scenario. Now for a player to win £2, they need to roll a 1 or spin a 1, or both. And so when a player rolls a 1, the assumption is that the player does not spin a 1 at the same time. And similarly, when a player spins a 1, the assumption that the player does not roll a 1 at the same time. Now we'll look at all of these separately. We'll start with rolling a 1. Now the probability of rolling a 1 is 1 over 6, because the number 1 appears once on a fair 6-sided dice. And so like we said, this comes to the assumption that we are not spinning a 1, which means we need to multiply this by the probability that the fair-sided spinner will not land on a 1. We have a fair 5-sided spinner, and the probability that it won't land on a 1 is the probability that it will land on any other number, and that's equal to 4 over 5. And so this part in the brackets is the probability that the player rolls a 1. Now like we said before, we're looking at the word or, which means we can add this next bit of probability. Now the probability that a player spins a 1, or to spin a 1 in a fair 5-sided spinner, we have 1 over 5. But just as before, this comes with the assumption that the player is not going to roll a 1. And so the likelihood of a player not rolling a 1 is the probability that a player will roll any number other than 1. Now in a fair 5-sided dice, this probability of not rolling a 1 is equal to 5 over 6. And so 1 over 5 multiplied by 5 over 6 is the probability of spinning a 1. Now we need to add the probability of both. And so the probability of rolling a 1 and spinning a 1 at the same time is just as we did before, which is 1 over 6 multiplied by 1 over 5. And so when we simplify this equation, we have 1 over 6 multiplied by 4 over 5, plus 1 over 5 multiplied by 5 over 6, plus 1 over 6 multiplied by 1 over 5, we will get an answer of 1 over 3. And so we can see that a third of players win £2. So a third of the total number of 30 players is equal to 10. And so we can see that 10 players gain £2 each. And so David's loss is equal to 10 players multiplied by £2 each, which is equal to £20. Now we need to see how much profit David can expect to make. He starts off with £30, but then he loses £5 and then another £20. And so we can say that his total profit is equal to 30, take away £5, and take away another £20, which is equal to £5. So we can now say that David can expect to make a profit of £5. Now part A is worth 4 marks, so let's take a look at where these marks are allocated. Now the first mark is for identifying the correct process to find the probabilities of the winning scores. The probability to win £5 we said was equal to 1 over 30, and the probability to win £2 we said is equal to a third, and so these probabilities will give us that first mark. We said that the prize money was equal to 1 multiplied by £5, and then again 10 multiplied by £2, and so the total prize money would be equal to £25. The third mark is for completing the correct process to find the profit, which is the total amount of money he would make, take away the total amount of money that he would lose. We said that profit is equal to £30, take away £5, take away £20, and so this piece of working out will give us that third mark. And finally, that mark is for getting the correct answer of £5, allowing us to get the fourth and final mark needed to get full marks in this question. In part B, we're asked to give a reason why David's actual profit may be different to the profit he expects to make. And so his actual profit might be different because the profit that he expects to make is only a probability. It's a likelihood but not a certainty. For example, he expects 30 people to play, but more than 30 or less than 30 people might play, and this will automatically change the profit that he makes. And so we can now say that David's actual profit may be different to the profit he expects to make, because the profit that he expects to make is only a likelihood that can change, and so a different number of people might actually play the game. Now this statement will allow us to get the mark needed for part B, allowing us to get the full 5 marks needed for this question. In this question, we're told that triangle ABC has a perimeter of 20 centimeters. We're told that side length AB is equal to 7 centimeters, and that side length BC is equal to 4 centimeters. Now by calculation, we need to deduce whether or not triangle ABC is a right angle triangle. And so to begin with, let's assume that triangle ABC is a right angle triangle, and then we can prove otherwise. So if a triangle has a perimeter of 20 centimeters, and we're given 2 side lengths, we can find the final side length by doing 20 take away 7 plus 4. And so 20 take away 7 plus 4 is the same as 20 take away 11, which is equal to 9. And so we've found that the final side length is equal to 9 centimeters. Now 9 centimeters is larger than both 7 centimeters and 4 centimeters. And so now assuming that ABC is a right angle triangle, we can say that the 9 centimeter side length is equal to the hypotenuse, because the hypotenuse is always the longest side. Now it would be really helpful to draw a diagram to help us in our calculation. Now assuming that ABC is a right angle triangle, we have side length AB equals 7 centimeters, BC is equal to 4 centimeters, and now we found that the hypotenuse AC would be equal to 9 centimeters. Now to prove that this is a right angle triangle, we can use Pythagoras' theorem, because Pythagoras' theorem only works for right angle triangles. So given that ABC is a right angle triangle, that means that A squared plus B squared equals C squared, which means 7 squared plus 4 squared must be equal to 9 squared. So let's test that out. 7 squared plus 4 squared is equal to 49 plus 16. Now 49 plus 16 is equal to 65. But 9 squared is equal to 81. Now really we've already proved that because 65 is not equal to 9 squared, this can't be a right angle triangle. But we can go a step further as well. A squared plus B squared equals C squared, and so C squared is equal to 65, which means that C, which is the side length AC, is equal to root 65, which is equal to approximately 8.062 ... Now we know for a fact that the perimeter is 20 centimeters, which means that the final side length has to be 9 centimeters. But we assumed that triangle ABC is a right angle triangle, and if triangle ABC was in fact a right angle triangle, the final side length would be 8.06. This means that the perimeter would not be 20 centimeters, which doesn't work. So now that we've found out that the triangle cannot be a right angle triangle because the side length is not equal to 9 like it should be, we can have a final conclusive statement saying that triangle ABC is not a right angle triangle because the final side length is not equal to 9 centimeters. Now this question is worth 4 marks, so let's take a look at where these marks are allocated. The first mark is for deriving that AC is equal to 9 centimeters and identifying this as the hypotenuse because it's the longest side. Now the second mark is for using Pythagoras and saying 4 squared plus 7 squared will be equal to c squared. Now the third mark is for finding that c squared is equal to 65, but we know that c squared should be equal to 9 squared, which is 81, giving us that third mark. And now that fourth and final mark is for a concluding explanation that ABC is not a right angle triangle, using the evidence that the final side length should be 9 centimeters, but using Pythagoras' theorem gives a different and incorrect length, which proves that triangle ABC is not a right angle triangle. In this question, we're told that one sheet of A3 card has an area of 1/8 meters squared. And now the card has a mass of 160 grams per meter squared. We need to work out the total mass of 25 sheets of A3 card. So now let's think about the information that has been given to us. If a card has a mass of 160 grams per meter squared, that means in 1 meter squared of card, it has a mass of 160 grams. Now we're told that one sheet of A3 card has an area of 1/8 meters squared. So now we want to go from 1 meter squared to 1/8 meters squared in order to see the mass of one sheet of A3 card. Now to get from 1 to 1/8, we multiply by 1/8, which is the same as dividing by 8. Now doing the same thing on the other side, we'll do 160 multiplied by 1/8, which is 160 divided by 8, which is equal to 20 grams. So now what we found out is that one sheet of A3 card has a mass of 20 grams. Now we know that one sheet of A3 card has a mass of 20 grams, we can work out the total mass of 25 sheets of A3 card. So we said one sheet equals 20 grams, and so to get to 25 sheets, we need to multiply both sides by 25. So we can say that 25 sheets is equal to 20 multiplied by 25, which is 500 grams. And so we've now found out that the total mass of 25 sheets of A3 card is equal to 500 grams. And remember, it's always really important to keep the unit in the answer. Now this question is worth 4 marks, so let's take a look at where these marks are allocated. The first mark is for finding 1/8 of 160. So we did 160 multiplied by 1/8, which is equal to 20 grams. Now the second mark is for doing 20 multiplied by 25 in order to find the total mass of 25 sheets, which was shown in our working. The third mark is for getting the correct answer of 500. And finally, that fourth mark is for getting the correct unit, which in this case is grams. And like we said earlier, it's really important to make sure that we don't forget the units. And so we've now achieved the 4 marks needed to get full marks in this question. In this question, we're given the first 5 terms of a sequence, and in part A, we need to find the next term of the sequence. Now in order to do this, we need to find out the pattern to get from one term to the next. And so to get from 2 to 8, we add 6. And then to get from 8 to 18, we add 10. To get from 18 to 32, we add 14. And to get from 32 to 50, we add 18. And so we can already see a pattern in the intervals by which we add. We add 6 at first, and then 10, and then 14, and then 18. Well, now to get from 6 to 10, we add 4. And to get from 10 to 14, we add 4 again. And to get from 14 to 18, we add 4 again. So to get from the first term to the second term, we added by 6. Then to get from the second to the third, we added by 10. To get from the third to the fourth term, we added by 14. To get from the fourth term to the fifth term, we added by 18. So to find the next term in the sequence, 18 plus 4 is equal to 22. And so we need to do 50 plus 22. And so we found that the next term in this sequence is equal to 72. Now we're told that the nth term of a different sequence is equal to 3n squared take away 10. And in part B, we need to work out the fifth term of this sequence. Now the fifth term means that n is equal to 5. And so we need to substitute this in to the nth term of the sequence. So 3 multiplied by 5 squared minus 10 is equal to 3 times 25 minus 10, which is equal to 75 take away 10, which will leave us with an answer of 65. And so the fifth term of the sequence is equal to 65. And we get the 2 marks in this question for getting part A correct and for getting part B correct, allowing us to get the full 2 marks needed in this question. In this question, we need to write 504 as a product of powers of its prime factors. Now to do this, we can use a prime factor tree. We'll start with 504 at the top of our tree. Then we're going to have 2 branches on either side. Now at the end of these 2 branches, we need 2 whole numbers that multiply to give 504. And so for any number on our factor tree, we're going to circle the numbers which are prime. Or to find 2 numbers that multiply to give 504, let's divide 504 by 2. And so 504 is equal to 2 multiplied by 252. Now 2 is a prime number, so we can circle this number. Now we need to do the same thing for 252. And so 252 is equal to 2 multiplied by 126. And so you can choose any 2 numbers that multiply to give you 252. But often it's easier to divide by 2 when you can, because they tend to be easier to divide in your head. Well, now we have 252, which we've split into 2 and 126. Like we said before, 2 is a prime number, and so we're going to circle this. Now we need to split 126. And we can divide by 2 again. And so 126 is equal to 2 multiplied by 63. We're going to circle 2, which is a prime number. And now we're going to split 63 up into 2 numbers that multiply to give 63. We can't divide 63 by 2 because 63 is an odd number. But what we can do is find 2 other numbers that multiply to give 63. And so we can choose 7 and 9. 7 is a prime number, so we're going to circle it. But 9 can still be divided into 2 parts. And so we can say that 9 is equal to 3 multiplied by 3. Now 3 is a prime number, and so we'll circle both of the 3's at the end of our tree. Now we've reached the end of our prime factor tree, because we can't divide anything any further. And so to write 504 as a product of powers of its prime factors, we can multiply all of the prime numbers in our tree, which is why we've circled them. Now we'll cross our prime numbers off as we go along. And so we'll say 504 is equal to 2 multiplied by 2, multiplied by 2 again, multiplied by 7, multiplied by 3, and finally multiplied by 3 again. We can now simplify our answer. Well, 2 times 2 times 2 is equivalent to 2 to the power of 3. And then we have 7. And 3 times 3 is equivalent to 3 to the power of 2. We've now found that 504 is equal to 2 cubed multiplied by 7 multiplied by 3 squared, which we can write down in our answer box below. Now this question is worth 3 marks. We get the first mark for drawing a prime factor tree. We get the second mark for circling all of the correct numbers and finding that our prime numbers are 2, 2, 2, 7, 3, and 3. And our third and final mark is for getting the correct answer that 504 as a product of powers of its prime factors is equal to 2 cubed multiplied by 7 multiplied by 3 squared, allowing us to get the full 3 marks needed in this question.